Let's start with this webinar by adding a bit of context. We know that the ERTMS standard has been developed in the rail industry. Infrastructure managers must therefore either develop new lines or revamp the existing line to meet the standards. But one of the major problems is that we don't always have a database. We can sometimes have a track plan on paper or in PDF file, but this makes it difficult to develop the line in a modern way. It also means that all the project-related activities will be carried out manually, and it takes time and money, and it can lead to errors. If we look at the steps we've taken to achieve a project, for example, ERTMS level 1 or 2, we need to collect existing data from a track plan or database, but as I said, we know that it's not always the case. We need to remove the old equipment, equip the line with all the different objects with respect to the specification. And also, we need to perform a safe validation of the data and the configuration. At the end of this process, we must export the data and the track plan combined in a digital format. And as you can see, if we want to have a safe and fast process, it's essential to automate it. It also guarantees the data continuity and integrity, which is important when you're working with different teams on several sites. That's why we propose this solution, the CLEARSY Data Manager, which represents 4 activities that are combined together. The first one is the CLEARSY Data Viewer that allows an operator to draw segments or to edit properties directly on the track plan. There is the CLEARSY Data Generator that takes this track plan and adds automatically objects on it based on your constraints. Then the generation and its configuration is formally validated with the CLEARSY Data Solver or T2 certified tool that is already used in several projects all around the world. The last part that is quite nice is that you can see the results from the CLEARSY Data Solver directly on the track plan with the CLEARSY Data Viewer. It allows you to have some context for your analysis and a better understanding of the non-conformities found by the tool. By the way, when we say non-conformities, it means all the errors that can be found in the data by the tool that needs to be fixed or explained. For example, a property that is not compliant with safety rule, if a balise is too far from a signal or thing like that. If we take an ERTMS example to go a bit further, we know, for example, that trains must have a more precise knowledge of their location, which means that we will need balise groups. To ensure precision, we'll put all these balises in the periodic location. But if you put too many of them, you will have good and accurate location, that's not an issue, but the cost of the line will be quite high because of the wiring and the maintenance of the equipment. So you need to find a good balance between the safety and also the cost of your project. For example, if we consider ERTMS level 2, we know that the balise groups must be at around 2,000 meters to have a good balance. And now let's go into more details with a previous demo.
Thank you, Vincent. The demo will start with the CLEARSY Data Viewer. We will import a project with a PDF file behind the scene. After drawing the missing parts of the tracks and adding a signal, we will use the CLEARSY Data Generator to populate the database with balise groups and working zone using specific constraints. For the balise groups, it will be their position according to signals and the distance between themselves, and also some consistency in the packets. For the working zones, it will be their position according to specific balise groups, and also that they should not have any switches inside them. Then we will modify the database to have non-conformities, and we will run the CLEARSY Data Solver, our T2 tool, to raise those non-conformities. At the end, we will be able to visualize these non-conformities in the CLEARSY Data Viewer. So let's start the demo. After launching the tool, I will import the project that we have created earlier. As you can see, there is a PDF file behind the scene and some missing parts of the track. We can hide or show the PDF file behind the scene as you want. Now, I will draw the missing part of the track from here to here. I will then add the signal. We can also edit some properties. For example, I will update the length of the track. Then my signal is not at the correct position anymore. So I will update the abscissa, update its name and its ID. I will also make sure that it is correctly oriented here in up direction. We'll use the CLEARSY data generator to populate the database with the balance groups and working zones. The generation process takes few seconds. As you can see, if I move the signals, everything is recuperated because balance groups are linked to signals and working zones are linked to balance groups. I will modify the database now to have some non-conformities. I will delete this balance group and I will modify the NPIG packets of this balance. Then I will run the CLEARSY data solver to have some non-conformities. I will make it more useful from here to read the counter example. As you can see on the left, you have a global visualization to help you to easily navigate. You can also hide or show any kind of objects. The validation process is finished, so we can see the different non-conformities. Here, there is multiple non-conformities for the balance group I deleted. I will update its status as not OK and put a comment inside the tool. There is multiple non-conformities because there is multiple paths. So we put the same comments for each non-conformities. And after that, you will be able to see that the non-conformities is not orange anymore, but in red, because it is not OK. This particular non-conformities is about the NPIG packet that I've modified. There is also a non-conformity that I was not expecting. By reading the output message, I can clearly see that it is because of a 1 centimeter error. I will update the status of these non-conformities directly in the report to show you that multiple people can work simultaneously on the same project. So I'm going to save it and open it directly in Excel. As you can see, there is 4 rows for the validation rule. 3 of the rules are not OK, and these are non-conformities. Here, I will update the status as OK justified for the 1 centimeter error because of the computation of the extremities of the working zone. Here in this sheet, I can see that there is my comments from the tool. And the last one, I will put it as OK to show you that there is another color for OK. I will save my report, close Excel, and re-import it directly in the tool. I will be able to see that my new comments now in the tool as my OK is in green, and my OK justify is in blue. So let's recap all the modules we've been through. First one is the CLEARSY data viewer. It will help you to create and manage your database based on a PDF track plan or any other imported image. Then we used the CLEARSY data generator to automatically populate the database while respecting predefined constraints. This constraint can be written in various languages, such as Python or formal language. Since the tool supports multiple languages, we can reuse existing scripts from your process. Then, thanks to our historical T2 tool, the CLEARSY Data Solver, with extensive experience across urban and mainline railway projects in Europe and North America, we will validate the data. It detects errors in the data and presents them in plain English reports, making analysis way easier. Then the reports can be re-imported in the data viewer, allowing you to pinpoint the errors directly on the track plan for faster analysis. I will hand it over to Vincent, who will recap all the services we can provide.
Thank you. So the main thing that we want to say here is that with this global approach, we cover all the life cycle of the data, from data addition to generation, and finally to formal data validation and the nonconformities analysis. So that way, we can help you with the various parts of the process. The CLEARSY Data Viewer interface can be enhanced to meet specific requirements. We can offer training for operators and support for development of generation rules. But we can also develop the formal validation rules that you need according to the constraints and specifications of your system. You can reuse these rules on all of your projects to maximize the return on investment. And you will get a document listing all the checks performed by each rule, giving you a clear explanation of what's going on inside the CLEARSY Data Solver, thus avoiding a black box effect. The validation reports and the GUI of the tool can be customized to suit your needs. Finally, we can help you with the safety analysis of the nonconformities revealed thanks to many years of practice in the field. And this experience, our references go back more than 20 years ago, starting in 2003 with a CBTC project, and then we explore different projects such as ERTMS or interlocking. Also, some time ago, some years ago, we started working on track plan editors with Alstom and more recently with Siemens to analyze the nonconformities using the CLEARSY Data Viewer. The important message that we want to share here is that our tools are independent of each other, but they can also work together. So if you only need data validation, you will only use the CLEARSY Data Solver. But if you want to cover the whole process with your data, the whole life cycle of the data, you can take the complete solution. It's automatic, it's fast, and it's reproducible. So it means that you can test if you have a regression in the new version of your project easily. The validation tool is certified for SIL4 projects. And as I said earlier, you will have knowledge preservation, which means that if you have everything in the heads of your experts, the people who know how the system works, the fact that we write down everything on paper, you will have a detailed specification of every rule developed, of every validation performed. It will help you to understand what is being checked and how. And what's more, what if in 5 or 10 years' time, you need to revise something or dig into your specification for your project? Then everything is written down. You will also have a comprehensive and safe and complete traceability. It means that you will have a data coverage of what has been validated. For example, if you have an object or an object type that hasn't been validated by any rule, then you'll see it, you'll know it. The report is easy to read. It's written in English, as Bria said, and you know in advance that the message you'll see, you know it because we validate it together. And if there is something that is not clear enough, we can write it differently together. Also, you can see the nonconformities on the track plan with the CLEARSY Data Viewer, which is a great help in analyzing the problem and write down restriction of in your project or or justification of the non-conformity. And the last thing that is quite important is that the cost of these tools, of this process, is only covered by a few iterations. A recent example concerned the last Olympic Games in Paris, and as you know, the metro line was revamped. We used the CLEARSY Data Solver to check that the track equipment has been correctly integrated into the database. And compared to manual validation, we know that the cost and time has been divided by 3. And it means that your initial investment pays for itself in just a few months. Well, everything we said can be found on our website. There is all our offers and our tool descriptions. And if you have any question, project, or anything else, you can contact us directly at this email address. Also, Brieux and I will be in the business trip in Europe in June, so you can book a meeting with us. And we'll be attending the High Data Forum in Cluj and the CENELEC in Lille also in June. So don't hesitate to contact us so we can have a chat. Thank you.
Thank you.